Hey math kids, today we're going to talk about tangents, and we'll just start with an example. So it says find the equation of the tangent to this function where x equals 1. So what we're going to have is a parabola, and then at x equals 1 we have a line that just touches it. So right here where it touches is x equals 1. Okay, so the way that we do it is we want to find what this actual point is, and so we are going to just plug in 1 for x. So we go 1 squared plus 1, 1 plus 1 gives us 2, and so we have the point 1 comma 2. Now we're going to use point slope form, so y minus y1 equals m times x minus x1. So we have the y1 and the x1, because here's x1, here's y1, but we don't have the slope. And so what we need to do is we actually need to take the derivative of the original, which is going to be f prime of x equals 2x. And we want to know at that specific point, so we plug in a 1. 2 times 1 is 2. And so that means our m is equal to 2. Okay, now we're going to plug in all this information. So we're going to plug in this and this to this. And so we say y minus 2 equals 2. So this 2 came from right here, and then this 2 came from right here. Then we have x minus 1, and that's the equation of the tangent line. If you wanted to, you could distribute and add 2, whatever, but we don't need to take it that far because it doesn't ask for a specific form. So we can leave it in point slope form. Okay, it says find the equation of any horizontal tangents of x cubed minus 12x plus 2. We'll call this f of x. Okay, so this is going to be a third degree function, so it's going to look roughly like this. So we're expecting to have 2 horizontal tangents, because it's going to look something like that. Now, what we do is we find the derivative, and if you notice, the slope of a horizontal line is up 0 over 1 or up 0 over 10. It doesn't really matter, but the slope is going to be equal to 0 on a horizontal tangent. So we take the derivative, and that's our f prime of x. And then we set that equal to 0 and solve for x, and that will tell us the x values where these horizontal tangents occur. And that will be helpful for what we're trying to do. So we do 0 equals 3x squared minus 12. So we add 12 to both sides. 12 equals 3x squared divided by 3. 4 equals x squared. Square root both sides. So that's plus or minus 2. Okay, so I'm going to set up ordered pairs for the 2 points. Okay, now to find 2 points on the line, we're going to plug in each of these to the original. So I plug in a 2, I get 2 cubed minus 12 times 2 plus 2. 2 cubed is 8. This becomes negative 24. The 2 and the 8 become a 10. And I get negative 14. Okay, same thing, but I'm going to plug in a negative 2. So negative 2 cubed minus 12 times negative 2 plus 2. So that's going to be negative 8. That's going to be positive 24 plus 2. Add these together. I get negative 8 plus 26. And then we get 18. Okay. So we have those 2 points. Now, what did they want us to find again? Let's see. Find the equations of any horizontal tangents. And so, because horizontal tangents are, or horizontal lines are just defined by their y value, the y value on this one is negative 14. So y equals negative 14. And the y value on this one would be y equals 18. So those are the equations of the horizontal tangents. Okay, we're going to keep moving. So we're given y equals natural log of x, and then y equals negative 1, and then y equals ex minus 2. Okay, so it says show that the equation of the tangent line to this at the point where this is true is this. Okay, so we have a natural log function that looks something like that, and it's going to look like this. And so somewhere right here where we get negative 1, we need to show basically what that x value is the first thing we want to figure out. And so what we need to do is we need to solve for x at that point. And so if I plug in negative 1, and then I take the e of both sides, I get e to the negative 1 equals x, or 1 over e. And so we're looking at this, and then it mentions a tangent line, so we're looking like that. Okay. Now, what we can do after that is we need to take the derivative to find our slope, because we have a point that it passes through, and then we just need the slope. So we're thinking this thing again, y minus y1 m times x minus x1. Okay, so once again, this is our x1, this is our y1. We just need our slope, so we take the derivative. So y prime equals 1 over x. If you remember that the derivative of natural log of x is 1 over x. And if we're looking at the derivative at that specific point, we're going to plug in 1 over e to that. Okay, so what that is just e. So it's like saying 1 divided by 1 over e, 1 times e over 1, which is just e. So this is our slope. Now we can plug everything in. So I'm going to say y minus y1, so minus negative 1. The slope is e. Then we minus 1 over e. All right, this equation does not look the same as this, so we need to do a little bit of algebra. So first thing, I'm going to change that to a plus sign, and I'm going to distribute right there. So we have y plus 1 is equal to e times x is ex, so that's good because that's starting to look like that. And then e times negative 1 over e is just going to be negative 1. Then we subtract 1 from both sides, and y equals ex minus 2. We got the same answer, and so we proved that original statement to be true. All right. So we have 2 more examples, so we'll just keep going. All right, it says find where the tangent to y equals x cubed plus x plus 2 at 1 comma 4 meets the curve again. Okay, so we're going to have a third degree function, and there's going to be like a tangent here or whatever, and then it's going to cross again. So they give us the tangent area, so this is where it's tangent to, and then we want to find this other point. So first thing, find the derivative. So y prime is equal to 3x squared plus 1. Okay, and then we use our x value and we plug it in to this. So we get 3 times 1 squared plus 1. So 3, so this is 1 times 3. 3 plus 1 is 4. Okay. Okay, and then we're going to, that's our slope. We're going to plug it into y minus y1 equals m x minus x1. So I plug these in. Y minus 4 equals my slope, which is 4, and x minus my x value, which is 1. Distribute. So we get y minus 4 equals 4x minus 4. Add 4, add 4. So y equals 4x. Okay. So that is the equation of the tangent line. Okay. Now we want to know where this crosses this. Now we already know it crosses one place at 1 comma 4, but we want to find that x value of where it crosses again. So we're going to set these equal to each other and solve. So we have x cubed plus x plus 2 equals 4x. Okay. And then I'm going to just subtract 4x onto this side. And so we get x cubed minus 3x plus 2 equals 0. Okay, there's some stuff we can definitely do. If we, some factoring methods we really haven't covered. So I would suggest, I know this is kind of silly, but I would suggest just graphing this and seeing where it crosses. Now, we can try to do like a grouping thing like this, and then take out an x, and I don't even know if this is going to get us to where we want. No. Yeah, I don't think that's going to work for us. Okay, so what we're going to do is we're going to graph it. Okay, so we have x cubed minus 3x plus 2. And we're going to see just where that crosses the x-axis. Okay, we see 2 spots. So I'm going to go second calc. I'm going to go 0. It wants me to click to the left. Oops. Okay, so that's to the left of where it crosses. Now it wants me to go to the right. And then we guess. We click as close as we can to it. So it crosses at -2. Okay, if we go back there, we see the other one is at 1, and we already knew about that one, so I'm not going to write that down. So we know the x value of where it crosses is -2. So this would be at x equals -2, this point. And so we just need to plug that into the original. Let's see, we'll do red. And whatever that is, that'll give us the other point, the y value to the point. Okay, so this becomes -8, -2, +2, -2, +2 cancel, so we're left with -8. So those are the coordinates of that second point. All right, and we still have one more example. Okay, find the equations of the tangent line to this from 2, 3. So this is an external point. This is not on. So once again, we have like a third-degree curve. We have some point over here that's 2, 3, and then it's going to be tangent somewhere. Okay, and we are looking for. I mean, ultimately, we want to know the equation to this. Okay. So, oh wait, this is x squared. Sorry about that. So this is actually a parabola. All right. Same idea though. Same thing kind of plays a role, but it's going to be a little bit easier. Okay. So we can name this point a comma a squared, because if we plug in some x value, we would just square it to find the y value. Okay. And so if we take the derivative of this, our y prime is equal to 2x. And if we plug in that a value, we know that our slope is 2a. Okay, so we know the slope of our line. And now we can look at our tangent line using y minus y1 times m times x minus x1, and we'll just plug in these values. So we get y minus a squared, m is 2a, then we get x minus a. All right, and if we, put this in like slope-intercept form, we can distribute. So 2ax minus 2a squared, add a squared to both sides. So we get 2ax minus a squared. That's our slope-intercept equation. Now, what we know is that we want this to pass through 2, 3. And so if we plug in 2 and 3 for those values, we get 3 equals 2a, then the x value is 2 minus a squared. And then we can solve this for a, and that will give us that point. So if we multiply that, we get 4a minus a squared equals 3. Now I'm going to move everything onto the other side, so I'm going to add a squared, subtract 4a, add a squared, subtract 4a. So I get a squared minus 4a plus 3 equals 0. We can t-factor that, 1 and 3, make those both negative. A minus 1, a minus 3 equals 0. If we set each of those equal to 0, a minus 1 equals 0, a minus 3 equals 0, we add 1, a equals 1, then we add 3, a equals 3. Okay. So we have two tangents that pass through this point, and so we need to address both of them. And so what we can do now, we use this original equation, or not original, but the blue equation down there, and we can plug in these a values. So y equals 2 times 1x minus 1 squared, and then we plug in 3. Y equals 2 times 3x minus 3 squared. And so y equals 2x minus 1, and y equals 6x minus 9. Okay, and let's read the question one more time. It says find the equation of the tangent line. Okay, now if we wanted to, we could figure out where they cross, and all we would need to do for that is plug this into the original to see what we get out of it, and then plug the 3 into the original to see what we get out of it. The book goes through that, but it doesn't actually ask for that in the question. And so these are our two answers. If you need additional help, come to Math Lab. Until then, calculator.